In this video, I'm going to be going through the topic 3 review for the test. This first page of the packet is for the calculator portion, and the second page will be the no calculator portion. So, the first two want me to divide using long division or synthetic division. I'm going to use long division for my first example. So in that one, I write my divisor on the outside, and I write my dividend on the inside. I also want to pay attention to the dividend to make sure that all of my x terms are there. If any are missing, I want to fill them in with zeros. This one is not missing any, so I'm just going to write it out. Then what I want to do is I'm looking for what I need to multiply my leading term by to turn it into my other leading term. So they both have a 2 out front, but I need 2 more x's, so I'm going to multiply it by an x squared. Which is going to give me 2x cubed plus x squared. Then I want to go ahead and change my signs. This one's going to cancel out. 3x squared minus x squared is 2x squared. Everything else drops down. I want to turn 2x into 2x squared. I'm going to be multiplying by an x, so I write that up top. I'm going to take x times 2x plus 1. Which is going to give me 2x squared for my first term. X times 1 is x. And then I add down. Or change my signs first, and then I add down. So my 2x squareds cancel out. 7x minus x is going to be 6x. And I bring down my negative 8. I want to turn 2x into 6. That is going to be multiplying by 3. I also want to write my 3 up here. So that's going to give me 6x plus 3. I want to change my signs. 6x minus 6x cancels out. Negative 8 minus 3 gives me negative 11. Since I have a remainder, I'm going to add 11 over 2x plus 1, what I was dividing by, and the leftover number goes on top, or my final answer. On the second one, I'm going to use synthetic division. So to use synthetic division, I want to take my divisor and set it equal to 0. Then I want to solve for x, so I get x equals negative 4. That is going to be the number that goes on the outside. Then on the inside, I want to fill in with my coefficients. But notice, I'm missing an x cubed, and I'm missing an x. So I want to fill in zeros for those coefficients. I have 1, 0, negative 1, 0, negative 7. And I drop down my 1. Negative 4 times 1 gives me negative 4. 0 minus 4 gives me negative 4. Negative 4 times negative 4 is positive 16. Negative 1 plus 16 is 15. Negative 4 times 15 is negative 60. 0 minus 60 is negative 60. Negative 4 times negative 60 is positive 240. Negative 7 plus 240 is 233. So then I want to fill back in my x's. I always start 1 degree lower than I had, so I had x to the 4th. Now I'm going to start with x cubed minus 4x squared plus 15x minus 60. And then this last number is always my remainder. So I have plus 233 over x plus 4. If I don't have a remainder, then I just don't have a term over a fraction. Next one wants me to factor my polynomials completely. I have a special pattern in here. I have difference of cubes, which factors to a minus b times a squared plus ab plus b squared. Or I could also, this isn't on here, but I could also have the sum of cubes, which is going to give me a plus b times a squared minus ab plus b squared. So for this one, I want to find my cube root of x and my cube root of 8. That is going to be x is the cube root of x cubed. Cube root of 8 is 2. If I ever forget my cube roots on my calculator, I can go math, and then choice 4 will give me, math, and then choice 4 will give me the cube root. And then I type in my number, which gives to me is 2. Then I want to plug in, so I'm going to have x squared plus a times b, so 2x, plus b squared, which is 4. On number 4, I can factor by grouping. So I'm going to break these up into two groups. On my first group, I can take out a squared. That leaves me with 2a minus 7. On my second group, I can pull out a negative 4. Which leaves me with 2a minus 7 again. Then I'm going to put my outside terms together. I want to factor my first term because this is difference of squares. So I have a plus 2, a minus 2 times 2a minus 7. On this one, it follows the difference of squares pattern because they're both perfect squares. This first one's going to turn into 4z squared. I take half of my exponent. Square root of 1 is 1. So then I have a plus term and a negative term. This one is still a perfect square, so I can factor it more. I'm going to have 2z minus 1 times 2z plus 1 times 4z squared plus 1. Okay. Number 6 and 7 want me to list all the possible real solutions for the polynomial. Remember, this is p divided by q for all of my factors. P is my n term, q is my leading coefficient. So I'm going to start off by listing out all of my factors of p. This is just 1 and 3. Then I'm going to list out all of my factors of q, which is 1, 2, and 4. I want to go for all of my possible factors. I want to take all of my p terms and divide them by all of my q terms. So I have 1 divided by 1 is 1. And then I have 3 divided by 1 is 3. Then I'm going to divide everything by 2. So that's going to give me 1/2, 3/2. Then I'm going to divide by 4. That's going to give me 1/4 and 3/4. So these are all of the possible zeros to my function. Same thing over here. My q is 3. My negative 2 is p. So my possible factors for p are 1 and 2. My possible factors for q are 1 and 3. So then I just divide. That's going to give me plus or minus 1, plus or minus 2, because I take those and divide by 1. Then I'm going to divide them by 3. That gives me 1/3 and 2/3. It's always your factors of your constant divided by your factors of your leading coefficient. This next one wants me to write a polynomial function of f of least degree that has the rational coefficients and a leading coefficient of 1 in the given zeros. So I have 2. That one is going to be x minus 2. And then I have the square root of 5. Whenever I have square roots or imaginary numbers, this means I have matching pairs. So I'm going to have x minus the square root of 5 and x plus the square root of 5. Remember, for zeros, I always do opposite the signs. So I'm going to actually multiply these out before I mess with my x minus 2 term. So x times x is x squared. X times square root of 5 is square root of 5x. Negative square root of 5x and negative 5. And I want to combine like terms. So I have x minus 2 times x squared minus 5. And I want to FOIL again. So x times x squared is x cubed. X times negative 5 is negative 5x. Negative 2 times x squared is negative 2x squared. And negative 2 times negative 5 is positive 10. I should be writing parentheses here. And then I just want to write that this equals my function f of x. The same thing for 9. I'm going to have x minus 3. And then I have x minus 4i and x plus 4i. Because i's come in pairs. I'm going to multiply my i's out first. So that's going to give me x squared plus 4ix minus 4ix minus 16i squared. So my x minus 3 stays the same. Remember, i squareds are going to turn into negative 1. So I have negative 16 times negative 1, which is going to turn that into a positive 16. And I want to FOIL out. X times x squared is x cubed. X times 16 is 16x. Negative 3 times x squared is negative 3x squared. Negative 3 times 16 is negative 48. I want to rewrite this in highest to lowest for my exponents. And I also want to set it equal to f of x. Number 10 wants me to see if it's a zero of the function. I'm going to plug in and use synthetic division. So -1, and then my terms I'm going to write out is 1, 4, -7, -10. Bring down that 1. -1 times 1 is -1. 4 minus 1 is 3. -1 times 3 is -3. -7 minus 3 is -10. -10 times -1 is 10. So this one is a factor because this equals 0. If I get any other number, it is not a factor. So then I'm going to go ahead and write this out as a quadratic. I have x squared plus 3x minus 10. So I'm looking for two numbers that multiply to -10 that add to 3. Remember, if I can't figure this out, I can always do y equals, and I can do 10 divided by x. And if I go second table, I want to find I look at my x and y values and multiply those together. This one is, it should have been -10. So this one I want a positive 3, that's going to be -2 and 5. So x minus 2, x plus 5. This wants it in factored form, so I need to remember to put back in the 0 I started off with. I would add 1 back over, so that's x plus 1. And this function was named p of x. This one wants me to graph the following functions, identify the x-intercepts and the point where the local maximums and minimums occur, determine the intervals for which the function is decreasing or increasing. So I'm going to go ahead and type this into my calculator. I have -2x cubed minus 3x squared minus 1. So I'm going to go ahead and graph this. I want to figure out where my x-intercept is. I'm going to do second calc. I'm going to go to choice 2 for 0. I'm going to go to the left side, press enter, arrow over to the right, press enter twice. This one gets me 1.67, let's do 8. Then I want to figure out where my local maximum is, so I'm going to go second calc. I'm going to choose choice 4 for maximum. Remember, maximums are like mountains, so I'm going to go to the left side of that mountain, press enter, arrow over to the right, press enter twice. This happens at, when the calculator gives you a weird number with an e, it's really trying to say 0. So this happens at 0, -1. Then I'm going to do the same thing for my minimum, which are valleys. I'm going to go second calc, choice 3 for minimum. I'm going to arrow to the left side of that valley, press enter, arrow to the right, press enter. This is having trouble rounding again, that should be a 1. So then I want to go ahead and I'm going to sketch this out on my paper. This was a -1.67. And that was a -1. Okay, so I want to say my interval where my function is increasing. That means I have a positive slope. That is happening right here. So that I write this out in interval notation, so just using my x values, that happens between -1 and 0. Then I want where my function is decreasing, that's where it has a negative slope. Which is here and here. So that starts off at -infinity and it stops at -1. And then it starts up again at 0 and goes right forever. Number 12 wants me to find all of the zeros of this function by factoring the polynomial. So I can't factor it as it is, so I'm going to start off by graphing it. I'm going to go x cubed minus 5x squared plus 11. Ooh, I don't want to type this all in my exponent. minus 5x squared plus 11x minus 15. And then I just want to find 1, 0 where it's crossing on my graph, so I'm going to go second calc, 0. I want to see my cursor on the left side, I press enter. I arrow on the right side, I press enter again. So I have an x at 3. So I'm going to use synthetic division to simplify this. That is going to give me a coefficient of 1, negative 5, 11, negative 15. Pull this down. 3 times 1 is 3, negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. 11 minus 6 is 5. 3 times 5 is 15. It gives me 0, which it should because I know it's a 0. So I'm left with x squared minus 2x plus 5. I can't factor this nicely. So I want to use the quadratic formula, which remember is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. I want to identify my a, b, and c. My a is 1, my b is negative 2, my c is 5. Plugging in, I get x equals negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 over 2 times 1. Now I'm going to go ahead and simplify this. That's going to give me 2. Negative 2 squared is 4. Negative 4 times 1 times 5 is negative 20 over 2. 4 minus 20 is negative 16. So since it's negative, that means I'm going to have an I. And the square root of 16 is 4. Then I want to divide each of those things by 2. That's going to give me 1 plus or minus square root of 2i. So those are my zeros, and remember I found 3 at the beginning. Number 13 wants me to write the cubic function equation in standard form for the graph with a coefficient of 1. So I want to find all of my zeros. This is going to be x minus 2 times x plus 1 times x plus 2. And then I also want to find my y value, and this is going to help me. Nope, it's not necessary because it tells me it has a leading coefficient of 1. So standard form means I just multiply these out. I am going to actually multiply my x minus 2 and my x plus 2 together first, because I know that's going to give me a difference of squares. It actually doesn't matter which order I do this in. I could do it in the one I wrote it in. So it's going to give me x squared plus 2x minus 2x minus 4. And I'm still multiplying by the x plus 1. I combine like terms, so it's going to give me x squared. Those cancel out. Minus 4 times x plus 1. FOIL again. That's going to give me x cubed plus x minus 4x minus 4. Wait. This one should have been x squared. Then I just want to have f of x equals my function. This one wants me to describe the end behavior of my following functions. I'm not allowed to use my calculator. So this one is even and it goes down. I mean, it's even and it's negative, so it's going to go down. That means as I'm going to say x goes to infinity. So as x goes to negative infinity, this means as I go to the left side, my graph is going down. And then as I go to the right side, my graph is again going down. Over here, I want to look for my highest exponent. It's hidden in the middle. So this one is odd and positive, so it goes something like that. So as I go to the left side, my graph goes down. And then as I go to the right side, my graph goes up. Okay, number 3 wants me to consider the following function. What are my zeros? So I'm going to take everything that's factored. Oops, I didn't mean to write the parentheses. I'm going to set those equal to 0. So I'm going to add 3. This one I'm going to subtract 1. Divide by 2. I get x equals negative 1/2. For the paper version of the test, I think it has you write the multiple zeros more than once. So I'm going to write the negative 1/2 twice out on this review. Then to figure out my y-intercept, I want to plug in 0. So I'll do that. I have 2 times 0 minus 3 times 2 times 0 plus 1 squared. I could do this by hand, and I have to do this by hand because this is the no calculator. So I have 2 times negative 3, and then 0 plus 1 squared. 2 times negative 3 is negative 6. 1 squared is 1. So that gives me negative 6. And then this one is, I have 3 zeros, and my leading term is positive. So it's going to be something like this. So as x goes to negative infinity, my graph goes to negative infinity. And then as x goes to positive infinity, f of x goes to positive infinity. So I want to go ahead and graph this out. My y-intercept is at negative 6. And then I want to put my zeros on the graph. So I have 1 at 3, and then I have 2 at negative 1/2. This means it bounces. So I'm going to go like that, and then the 3 just goes straight through. Number 4 wants me to write a cubic function that passes through the given points. I'm going to start off, all of my zeros, I'm going to do opposite the sign in parentheses. Then what I want to do is I am going to multiply this out. So it's going to give me x squared plus x plus 5x plus 5, and then I still have this other term I need to multiply to. I'm going to combine like terms. It's going to give me x squared plus 6x plus 5 times x minus 4. And I'm going to keep distributing. So I have x squared times x is x cubed. X squared times negative 4 is negative 4x squared. 6x times x is 6x squared. 6x times negative 4 is negative 24x. 5 times x is 5x. 5 times negative 4 is negative 20. I'm going to combine like terms. So I have x cubed plus 2x squared minus 19x minus 20. And notice my y-intercept is 5, which is not this number I have right here. So I need to turn negative 20 into 5. The way I would do that is I would divide by 4, so multiply by 1/4, and then it needs to turn from a negative to a positive, so I have negative 1/4. I could distribute that all the way through, or I could just write the negative 1/4 out in front of the 3 values I had at the beginning. Both of those would be equivalent. Okay, there's a few more on the back. This one wants me to consider this graph. What are my zeros? So I take this and set it equal to 0. So I have 2, and then I'm going to write the negative 1 twice. I'm going to graph those on my paper. My y-intercept I find by plugging in 0. Oops, not x0. So I have 1/4 times negative 2 times 1 squared, which is negative 1/2. So this one, again, is cubic and it's positive, so it goes something like that. As x goes to negative infinity, f of x goes to negative infinity, and then as x goes to positive infinity, my graph goes up. then I just want to go ahead and graph this. The -1 is where it bounces. So it looks something similar to this. So same thing on number 6. I want to go ahead and take my stuff in the parentheses, my factors, and set those equal to 0. I've already done x plus 3 because my video kept stopping. I'm going to do the x minus 2 and set that equal to 0. Then I'm going to subtract 3 on both sides. I get x equals -3. Over here I add 2. I get x equals 2. So I'm going to have zeros at -3 and 2. And I'm going to write the -3 out twice, because it happened twice, and then the 2. My y-intercept is when I get what I get from plugging in 0, so I have -1/2 times 0 plus 3 squared, 0 minus 2. So that's -1/2 times 3 squared times -2, which is -1/2 times 9 times -2. -1/2 of 9 is -9/2 times -2 is +9. So I'm going to go up there and graph that. Oops, that one on the wrong. Then this one, because it's got a negative coefficient out front, it's actually going to look something more like this. And it bounces at my -3, so it looks something like that. So, as f of x, nope, as x goes to -infinity, so as the graph goes to the left, my function goes up, and as x goes to the right, my function goes down. And then 7 just wants me to factor. So on this first one, I'm going to do grouping. My first group, I can take out a 2x cubed. That leaves me with x squared minus 1. Over here, I can take out a -16. Again, I have x squared minus 1. That's good. They should match if I'm doing by grouping. I have 2x cubed minus 16 times x squared minus 1. This first one, I can pull out a 2. That's going to give me x cubed minus 8. And then I have x squared minus 1. This is a difference of cubes. I wrote down that formula earlier, but I'll write it down again. Oops, this should be a cubed. So I'm going to split that up. It's going to turn into x minus 2, then x squared plus 2x plus 4. And then my x squared minus 1 is the difference of squares. Those are both perfect squares. So I'm going to have x minus 1, x plus 1. And this is as factored as my answer gets. For B, it's in a quadratic form. Instead of, so I have something like 3x squared squared minus 13x squared plus 4. So I'm going to use my AC method here. My A is 3, my B is -13, and my C is 4. AC is 3 times 4, which is 12. I'm looking for two numbers that multiply to +12 and add to -13. It's -12, -1. So I'm going to split this up. I have 3x to the 4th minus 12x squared minus x squared, oops, and then plus 4. Then I want to factor by grouping here. So in my first group, I can take out a 3x squared. It's going to leave me with x squared minus 4. In my second group, I can take out a -1. Again, leaves me with x squared minus 4. I'm going to put my two outside pieces together. I have 3x squared minus 1, x squared minus 4. X squared minus 4 is a difference of squares, so I can split that up. Oops, I'm splitting it up. So we're going to have x minus 2, x plus 2.